Okay, let's move on to the next public lesson. In 7th grade, we have Jake Diston, who's looking at algebraic equations, inequalities, and properties. This is a great lesson, especially for kinesthetic learners, because there's a whole lot of moving around the classroom that the kids are doing. He starts by giving his students pieces of paper with different symbol strings on them. Some of them are equations, some of them are inequalities, some of them are properties, and he asks them first to start looking at that whole number string. Don't just think about individual procedures or steps, and that he wants to see these symbol strings as mathematical objects with their own unique set of attributes. Now he's not asking them to do this by saying, this is the commutative property, let's memorize it, students. But by giving the students all of these different strings and saying, categorize yourselves. How are these similar to each other? How are they different? Find other people who are like you. So in the beginning of this lesson, Diston and his colleagues are talking about how do these students look at these mathematical expressions as objects, and that they are linking this to some of the Van Healy levels of how students perceive geometrical figures and their attributes, how students move from thinking that a shape looks like a house or a door. But with explicit experience, students begin to notice things like angles or corners, the size of the angles, the number of angles. So this is similar to how they're trying to get these students to think about the mathematical objects that this team is presenting to them. When you move into the lesson itself, these students are doing a whole lot of walking around. Almost the whole time it seems that they're on their feet, talking to each other, gathering around the board, analyzing the different symbol strings, putting them up there, trying to get them into groups that make sense. And there aren't necessarily particular right answers that they're going for. So some might belong or seem that they belong to more than one group. Just as with the other teachers here, there are student worksheets here. This is and teacher materials. Here's the lesson itself that Diston developed with his colleagues, as well as the worksheets that they're using. Here are the symbol string cards that they were using. So you can see that some of these are different in interesting ways. All right. So how would they figure out which ones are similar to each other based on these different strings? Then as well, we have these examples of student work. You know, what are the differences between equations, inequalities, and expressions? So equations have an equal sign, expressions have no equal sign, inequalities have either this, 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 or this, and so on. But you can analyze these students' work, compare it to your own students, or your own understanding even of these content areas. As he goes through, you know, first he's asking them to do a lot of this group work, saying how do they use this mathematical vocabulary? What's the purpose? How do they understand that purpose? As you click here, I want to remind you that each of these segments has part A, part B, part C, part D. So make sure that you're, as you're exploring this lesson, that you're not skipping over some of these segments here. These are largely just carved up on the kind of different conceptual tasks that Diston has his students working with. This is the second problem, again, which has parts A, part B, and part C. You can see that he's trying to get them to say, okay, well, how are these two similar to each other? How do they, are these examples of equations or of properties? And then when he closes the lesson, he's asking them to discuss how did these groups sort these symbol strings? How did they come to the understanding of which were equations, which were inequalities, and so on? Again, this has 4 different parts, so as you go through, you can see Diston working with his students on these issues. And then afterwards, you can see in the faculty debrief, which is again fairly lengthy, so there's 5 parts to this. How did the faculty observe the students' understanding building over the course of the lesson? And what were those outcomes? What were even some next steps? Because none of these lessons are intended to be, here's the end-all be-all of teaching algebraic equations, inequalities, and properties. But here's one very robust, intensely reflected upon, planned, analyzed piece of instruction. But even that piece of instruction is connected to what came the day before and what came the day following. And so these teachers are talking about, you know, how would these techniques work in a real classroom, quote unquote, where there aren't 6 teachers observing and cameras and so on. We understand that there is a certain observer's paradox to documenting practice in this way, but I think that from watching a lot of different classrooms, it does appear that the students, while they're conscious of the camera at the beginning, by the end they're more focusing on the teacher, his relationship with them, and the mathematics and the learning outcomes they're expected to demonstrate. So again, you have the transcript here, the student worksheets, and several examples of the student work that can support your understanding of distance lesson. We'll move on to the next one now.